Good day everyone. For today's video, our focus is all about derivative tricks, and specifically our focus is all about derivative of a quotient. So say for example, you are given with a function, say y equal to x plus 2 all over x plus 3. So commonly, if you find the derivative of this function, all you have to do is, say for example, you are given with a function f of x equal to u over v, or a function of the form u over v. So if you are going to find the derivative of that function, it must be v du minus u dv over v squared. So all you have to do is just to get the function at the v first, the denominator, then derivative of the numerator, minus the numerator derivative of the denominator, then denominator squared, or somehow low the high minus high the low over low squared. So actually, there are some more techniques that you can use in finding the derivative of a quotient, aside from using this quotient rule. So you can also apply the 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 natural logarithm. But before that, let us review. If you are going to find the derivative of natural logarithms, for example, ln of u, this is just equal to u prime over u. And if you are going to find the derivative of the logarithm of u base a, this is just u prime over u ln of a. Okay, and aside from that, we will also recall some properties in logarithm. If we have logarithm of u times v base a, this is just equal to the logarithm of u base a plus the logarithm of v base a. And also, if we have logarithm of u over v base a, this is just equal to the logarithm of u base a minus the logarithm of v base a. And also, for the power rule, if you have logarithm of u to the power of p base a, it can be written as p logarithm of u base a. So that's it for the properties of logarithm. So what we're gonna be doing here is, we will not we will not we will force that we will not be using the quotient rule. So what we're gonna be doing is, we are going to take the logarithm both sides, the natural logarithm actually. Then after that, we will apply the properties of logarithm here in the right side. So we will just copy the left side. So here it will be from the quotient rule, it will be ln of x plus 2 times a plus rather ln of x plus 3. So after that, we will now get the derivative both sides of our equation. As we can see, we will just apply this one. So it will be the derivative of the function y in terms of x is just this one. So it will be y prime over y. And this one, the derivative with respect to x. So you have the derivative of x plus 2 is just 1, because the derivative of x is 1, derivative of 2 is 0. And you copy the function x plus 2. So it's very easy to find the derivative of this. And next is 1, and it will be x plus 3. So as you can see, let's erase this first. So as you can see, we are almost done, because we are looking for the y prime. And if we are going to look for the y prime, we will just have to transfer this y to the other side. But again, the y is not yet in terms of x, so we will be using this again. So we will transfer y to the other side and we will be substituting this. So it will become y prime equal to, supposedly it is y because you will just multiply it here. You will be using this directly. So x plus 2 over x plus 3 times this portion, 1 over x plus 2 plus 1 over x plus 3. So the next thing is we are going to distribute it in each term. So it becomes, if you distribute it here, it will only be 1 over x plus 3. And if you distribute it to the other side, the other term, rather, it becomes x plus 2 over x plus 3 squared. Then we will combine. So obviously the LCD is x plus 3 squared. So it becomes here only x plus 3. And here is only negative x minus 2. So if we will simplify it further, this x will be cancelled out. 3 minus 2 is 1. So it is just 1 over x plus 3 quantity squared. So that's it. Instead of using the power rule, we can also use the natural logarithm. And we will also have one more technique to use. So it's actually a little bit quicker than the two solutions or the two methods in finding the derivative of quotient. So the technique is this. So all you have to do is first, if you have the derivative of your function of the form a f of x plus b over c f of x plus d. By the way, this technique will only be applicable if these two are the same. The functions are the same and a, b, c, and d are constants. So just like what we have a while ago, y equal to the given is y equal to x plus 2 over x plus 3. So in this case, as you can see, your function is x, this portion. Your a is 1, there's 1 here. Your b is 2, your c is 1, and your d is 3. So if you are going to have this one, actually the formula there is only f prime. Actually, you are just using somehow the same with the process in finding the determinant of a matrix. Right minus left. So you have AD minus BC. And you just have to take the square of whatever denominator that you have. That's it. So if you're going to find the derivative of this, it will be y prime equal to. So the derivative of your function, in this case, your function inside is the x. So the derivative of x is just 1. And then you a times d. 1 times 3 is just 3. Minus 1 times 2 is just 2. And here it becomes the denominator squared. So in this case, x plus 3 quantity squared. And actually, this is just 1, x plus 3 quantity squared. So as you can see, it's a little bit quick than the previous method that we've shared. So all you have to do is just remember this formula and you can apply it in the derivative of a quotient. Let us have one more problem. Let's have one more. Okay, let's have this one. Okay, let's apply this technique, this trick, this formula in finding the derivative of a quotient. So let us have, say for example, I ask you to find the derivative of, say, uh, 3x squared plus x, 3x rather, plus 1 all over x squared plus x minus 2. So in this case, as you can see, it seems that we cannot use this formula because these two functions are not the same, but we can do something here so that you can really see that these two functions are the same here. So what we will be doing is you can rewrite this as 3 times the quantity of x squared plus x plus 1 all over x squared plus x minus 2. And I think it is now clear that the function that we have is x squared plus x. And your a is 3, your b is 1, your c is 1, and your d is negative 2. So if you are going to perform the derivative of that function, so the derivative of that will be now, let's continue it here in this portion. Let's just follow this one. So first is the derivative of your function. Obviously, the derivative of x squared is 2x. The derivative of x is just 1. And you multiply a and d. So it is negative 6 minus 1 times 1 is 1. And you copy the denominator, x squared plus x minus 2 quantity squared. Then all you have to do is just to simplify your answer. So in this case, it will be now equal to 2x plus 1 times negative 7, or somehow it can be written as, just simplify it further. So negative 7, so it's negative 14x minus 7 all over x squared plus x minus 2 quantity squared. Just quick as that.